All right then. So, thank you everyone for coming. Let's have a good and educational night tonight. My name is Larry Garfield. You may know me online as Krell. If you want to make fun of me on Twitter during this talk, that's where you do so. I generally encourage it. I am a staff engineer for Typo3, the open source PHP CMS. I'm also a member of the PHP Fig core committee. For those not familiar with the Fig, it's kind of like the United Nations of PHP with all the good and bad implications that has. Take your pick. I've worked on a number of PHP core RFCs, mostly doing the English writing part for someone else's work. And author of a couple of books on PHP, most notably Exploring PHP 8 and Thinking Functionally in PHP. Yes, functional programming in PHP is a thing. It works. I have a whole book on it, and we're giving away a copy of that book at the end of the session, so stick around. But tonight, let's talk about arrays. PHP loves arrays. They are everywhere. They are the iconic PHPism. You know someone is a PHP developer when they use associative arrays everywhere. There are over 80 array functions in the PHP standard library just working with arrays. And that's bad. This is not actually a good thing, I would argue, because while arrays are popular, they come with an array of problems. Yes, the jokes are going to be that bad tonight. You have been warned. What do I mean? Well, they actually have very inconsistent behavior. The way they behave in PHP is not consistent or predictable. They have no type safety to speak of. If you have an array, the things in it might be integers, they might be strings, they might be user objects, they might be a little of each. You have no way to know which it is. And if you guess wrong, things break. Because there's really no built-in error handling to speak of either. The error handling is die. And as we'll see, the performance is actually pretty terrible compared to other options. And if you're used to some other language like C, you're used to arrays being faster, not in PHP. Of course, the other big problem is that PHP doesn't actually have arrays. Huh? Okay, before we go on, we do need to address the elephant in the room. I warned you. What exactly is an array? Well, in programming language speak and computer science parlance, an array is an ordered sequence of values of the same type identified by their offset. That is what array means to everyone except a PHP developer. This is not what PHP has. The thing PHP has and it calls an array is not this. What PHP has is an associative array. An associative array is an arbitrary key value index where you put in a key and it maps to a value. In most other languages, this is called a map or a dictionary, or the term varies a little bit language to language, but this is the more common term, is map or dictionary. Numeric arrays, that is zero indexed arrays where the key goes up by 1, are implemented via a hack. They are not actually something the language has at all. They are a hack added onto associative arrays to make them work. And you really get no type guarantees at all on the value or on the key. The key can be an integer or a string, and if you try to set a key as a float, it rounds down to the nearest integer silently, because that makes sense. Let's look at an example here. We have a variable a. We assign it's an array. We assign 2 values to it, a and b, and we print it out, and so we get index 0 is a, index 1 is b. Cool. So now we unset a value out of it and push another value into it, and now what do we get? A gap. The empty braces does not mean add to the array. It means make up a new integer key based on an internal counter plus 1. And that counter does not reset really ever. So if you add 50 items to an array, remove them, and add 50 more, your indexes will all be starting up at 50 or 51 or whatever. They're not actually a sequential array ever, except by chance, which means they're unreliable. What happens if you take an array and try to iterate over it with a for loop? we get an undefined offset because there is no index 1 in that array anymore. Even something as simple as a for loop is inherently unreliable in PHP because of arrays and how they work. Because here on line 2, AI will break. Just referencing AI is a threat to your code, which if you've been paying attention to the media, you already know that AI is a threat, but again, different matter. There is also a security issue. This is real code out of the Drupal database layer. Does expansion of placeholders, so you can say, where in question mark, and then provide an array for that placeholder, or placeholder and then by name and then an array, and it'll expand that single placeholder out into multiple placeholders by iterating over each of your values in your value array and building a new placeholder key and sticking that into the query string. Cool, useful functionality. It actually makes it a lot nicer to work with. What happens if that data array has string keys instead of numeric keys? That's right, you have an SQL injection attack. This is the code behind Drupal-geddon, the worst security hole in Drupal history. And this was caused by a combination of a hole in the form API and a lack of type safety. Lack of type safety in arrays caused the worst security hole in Drupal history. Now the fix for that is nice and simple. Call array values, which returns a new array that is re-indexed at 0. But the fact that you have to think about that to avoid major security holes is a problem. The real issue here is that PHP uses arrays instead of purpose-built data structures. And that is almost never what you want. So what do you want? What's the better alternative? Well, purpose-built data structures. Let's do that. What does that look like? Let's see. Let's start off with just lists or sequences. For trivial cases where you just have a list of values, okay, arrays can work, but they break down very quickly. We just saw 2 problems where code fails or you have a security hole, even for simple cases of just using 2 or 3 values in an array. What can we do instead? Well, let's start with array object. Array object is a built-in object in PHP that behaves mostly like an array. It has the array access interface on it. It has countable. It has traversable. So you can use it almost like an array, but it's actually an object, which means you can also subclass it to create a type-specific array. Now, to be clear, data structure, when we talk about data structures in PHP, we almost always mean object. Classes and objects are what we mean when we talk about data structures. Slightly different in other languages. In PHP, we mean objects. What does typed array look like? Like this. We have a hidden constructor. So that's just out of the way. You can't access directly. You have to create a typed array through this forType method that we add up at the top. And that takes a type string, name of a class, that we just save. And then when we try to assign a value into this typed array object using offset set, we check, is the value being passed in of the type that we want to be holding here? Is it of type this type? If not, throw a type error. If yes, okay, go ahead and do what we were already doing. You just call the parent in array object. And what this means is we can now know if we put a point class, in this case, we create a typed array for points, and we can now assign points into it. And then when we for each over that list, we know, guaranteed, everything coming back is going to be of type point. If it isn't, it would have blown up already. So our code now is safer. We can assume it's going to be a point correctly. If you try to put in something else that is not a point, like a string or another object, then it'll blow up with a type error, which is what we want because you're doing it wrong. And we can catch that explicitly. This is already more powerful and safer. But what if we want to ensure a sequential list? We don't want to deal with string keys. We just want a list. Well, we don't use array object in that case. We can just make our own object. In this case, we have a class called typed sequence. It's going to implement countable and iterator aggregate. Internally, we're going to track a type, just like before, and we're going to create it using a for type static method, just like before. And we're also going to have an internal array called values. And when we go to add something to it, we have an add method, which you pass a value to, and we do that same type check on and reject it if it's not of the type we want. And if it is of the right type we want, add it to the internal array, and then we're done. And then count is just counting the number of items in that internal array, and get iterator then, which is how you would iterate over this object, just takes the internal values and casts it up to an array iterator, so it'll iterate nicely. Yes, we are using an array internally to this class. That's okay, because now it is an implementation detail of this object, whereas anyone using this object has no ability to get tripped up by the inconsistencies of arrays. We are handling all of that here in this class. You can add other methods too, like a has method, or whatever other methods you feel like. We'll see an example of those in a bit. But this gives you more power and more reliability in about 20 lines of code, give or take. That is then safer to work with than native arrays. Cool. Of course, they're passing by reference, not by value, like arrays, which means you can modify them, except no, actually, objects also pass by value. If you think objects pass by reference, then you've been lied to. But yes, they can be modifiable, but that's because they pass by handle, not by reference. And what? Yeah, it's a little bit confusing. Bear with me. An array or a primitive passes by value. An object is split into two pieces. There's the actual object in memory, and then there's a handle to it. That handle is what's actually associated with the variable name, and that handle passes by value. Makes it subtly different than passing by reference. But it does mean in net that if you pass an object, you can modify that object, which gives you spooky action at a distance, because you can pass a value to a function or to a method, and even though you don't take that value back, it may have been changed by that object, or by that method, and that's not always good to have objects and values change out from under you. So that's bad. But it's also really easy to fix ourselves. For example, here's an immutable typed sequence. Works the same way as the last one, so most of the methods are the same. All we're going to do differently is our add method now, after it's done the type check, creates a new object and gives that new object a values array that is all of the values from the first array plus the new value, and then returns that new object. This object has not changed. We now get a new object back that has all of those old values plus one. And remove does the opposite. If the value is found in this list, then all right, make a new object that has all of the values of the original object of this, except the one we're trying to get rid of, and reindex all of those back to 0 by calling array values on line 18, and then return that modified object. So now we get back a new object that is the same as the old one minus the other value, but still with consistent 0-based keys. And if the value isn't there, then as an optimization, we just return the object as is, because nothing would have changed. This is actually really efficient in PHP compared to a lot of languages because of copy on write. PHP is very memory efficient and will not duplicate memory unless it actually needs to. So in most cases, trying to be smart about not duplicating values is actually going to backfire, because you are trying to outsmart the engine, and the engine is smarter than you are. You can also then go ahead and add whatever lookup methods you want to this object as appropriate. If you don't like the fact that this is kind of generic, okay. Doing a custom version for one specific type is really easy. Instead of using manual checks, we'll just use types. We have a sequence that's specific just for points. And so the add and remove methods check for points specifically. And cool. Again, about 20 lines of code. It's really easy. You can make one of these for any given object you want to have a list of. And you get all of the benefits we've talked about. You can even make it sure it's unique. If you want to have a list of objects that is ordered, immutable, and unique, then only a slight change. In this case, we split out that array search to a has method. And then when we go to add a value, if it's already there, then we don't do anything. We just return the value as is. And if it's not already there, then we do the same thing as before, return a new object that does have it added. Arguably, I should not be using inheritance here, but it fits on a slide, so meh, debate for another time. Okay, what if you care about the order? You want them to come back in a certain sort order. You can do that too. We take that set and extend it. This time, instead of for type taking a string, just a type, it takes a type and a comparison function. And it's otherwise basically the same. But when we go to iterate over it, we first call usort with our custom comparison function. So we can sort the values in this ordered set however we want just by saying, here's how to sort them. And then we can use it like this. We create a comparison function, takes 2 points, and returns them in order using the spaceship operator introduced in PHP 7. And we're going to sort first by X and then by Y. So we want the points ordered, all of the low X's first, and in case of the same X, then we sort by Y. Now we create an ordered set for type point, give it that comparison function, and we just throw a couple of points into it in random order. Then when we go to for each over them, then they get sorted at that point, and they come back in the order we want. At this point, it's probably easier to, passing the comparison function in is a little bit clunky. At this point, it's probably easier to just go ahead and make a purpose-built class. Call it point set. So there's a unique list of points that come back ordered using the exact techniques we've talked about all this time. We're going to type check it on the has, add, and remove methods. We built in a comparison method. And when we call getIterator, we first sort the values and then return an array iterator of that. What have we gained through all of this? We now have type-safe lists. We have sequence guaranteed lists, lists that we're guaranteed are not going to have random array keys. We know that they're going to be zero-based numbers always. If we want an immutable guarantee, we want to guarantee a value is immutable, we can do that. We have an API that is very self-documenting and describes what it's doing, has, add, and so on, and any other methods you want to add as well. We can encapsulate additional functionality, either just the array and the list-like behavior, or other stuff specific to a set of points. What makes sense for a set of points in your domain? I don't know, it's your domain, you tell me. But you now have a very clear place to do this operation on a collection of points. Every example we showed here took me less than 10 minutes to write. Every single example took me less than 10 minutes to write. Most of them, I think really all but one, took me less than 5 minutes to write. Are you going to use exactly this code? Probably not. Point here being implementing something like this for your specific use case that is part of your domain model is really, really easy and gets you a huge array, pun intended, of benefits. One difference, though, is that we can't pass them the same way. That is, we can't type hint on array anymore. And you want to type hint things. You want to type check your code always. But an object is not going to pass a array check. So what do we do about that? Well, there's two options depending on if we care about the type of the things in the list. If we care about the type of things in the list, then make it a type specific list. We just saw how to do that. It's pretty simple to do. You have product list, point list, user list, whatever, and the code is fairly simple. Now you have a domain object that's part of your API that you can do things with, not just pass around, but also you have a place to put business logic that makes sense to operate on a list of products or a list of points or a list of users or a list of whatever. If, however, all you care is that you want to for each over something, then you don't want to type it as an array. You want to type it as for eachable, or in PHP speak, iterable. Iterable is a type declaration in PHP that means something is an array or an object that implements traversable. Traversable is an interface that is implemented by iterator and iterator aggregate. And you can implement those yourself. But the really cool part is generator objects. Generators are iterators that you can pause halfway through. They are fantastic. If you have not used generators yet, you want to. Generators let you create a lazy stream of values. And you can create those values lazily if you want to. You can pluck them out of a more complex structure and flatten them into a linear stream. And often it leads to very much simpler code than trying to do this on arrays. As an example, PSR 14, the event dispatcher interface developed by the PHP Fig, has a method in it called getListenersForEvent, which takes an event object and returns a list of callables, a list of things that you can then call with that event. But we don't care if that list is created in advance or on the fly. We just know we're going to for each over it. So we tag it as iterable, which means you can return an array or you can return something else. This is how it gets used. We're going to call getListenersForEvent on line 6. And then for each of those listeners, which is a function or a method or whatever, we're going to call listener on that event. And then there's some other stuff here you don't need to worry about now for our purposes. But that's really all we're doing. So all we care is if we can for each, which makes it possible to have complex arbitrary logic that you don't need to worry about the details here, looks at some internal data structure, iterates over that data structure, compares it against things in the event, checks to see if methods exist on objects, and then yields back a callable, which is a subject object and a method on it. And that's it. We don't need to build up the list in advance. We don't care how many there are. We just yield that value. And then that value that we yielded gets used in the for each loop. And the next time through the for each loop, the code picks up again at line 14 and then keeps continuing. So we can now have an infinite number of values returned with constant memory. That also means it's now trivial to concatenate lists together, including lazy lists. This is out of the PSR 14 utility library, Event Dispatcher Util. We have an aggregate provider that has an array of other provider objects internally. And when you call getListenersForEvent, it just checks each of those in turn and calls getListenerForEvent on that. What comes back from this object, from calling getListenerForEvent, is still a stream of callables that are produced lazily, and we don't care that it's lazy. Maybe some of them are lazy, some of them are not, doesn't matter. But this makes working on a sequence of values so much easier than with arrays. Sometimes you'll want to use an array, but most of the time, tag it as iterable, so you have the option to use either one. But we mentioned before, PHP has like 80 array functions. that you then can't use on generators, you can't use on objects. So what about them? How often do you use them? Very few do I ever use with much frequency. There's only like 2 or 3 that I've used with any frequency at all. But you can use them as an internal implementation detail. You have a list of things. That list object has an array inside it, and you can call those array methods on that structure if you need to. And if you really need to expose it as part of the API, it's actually not hard to re-implement these. Far and away, the most common functions used in my experience are map and filter. Here's map and filter that works on any iterable. That's it. It's easy. Map is iterate over a list, and yield, so it's iterable and returns, it's a generator, yield back, calling that operation on that value. Filter, iterate over the list and yield just those that pass the filter check. That's it. You can implement the others if you need to. You probably don't need to. But if you do, you can put them into an object. If you really want to go all the way, you may have heard of collection objects. Some frameworks have collection utilities of some kind. Let's build one. Let's build one that is lazy, immutable, functional, and short. So we have a class called collection. It implements iterator aggregate. Cool. And we're going to hide the constructor. You can only create it either from passing in a generator. So the collection is a generator that we store internally. Or if you pass an iterable, then we'll create a generator on the fly. That's lines 12 through 16. That just iterates through that list of values. So either way, we get a generator. And then when we want to iterate over the collection, we just call just for each that calls get iterator, which invokes the internal generator and returns that. So no matter what, you always end up working with a generator of values. If we want to add values to it, then we call append, which adds collections together or adds iterables together. And all that does is create a new collection that will yield from its own generator first, and then from all of the others after it. This is the same concatenation we saw earlier with the aggregate provider, where we're just streaming collections one after another. If we want to add individual items, well, a list of items is, oh, that's an iterable, that's a list. So we're just appending that list. One is a special case of many. If we want to now operate on it, we can call map. A map routine on this collection is the same thing. We return a new collection with a generator. That generator works by iterating over everything in this object's generator and calling the function on that value. That's exactly what map does. You could make filter too if you want. And then finally, since it's all just generators all the way down, we have a toArray method that flattens everything out to an array. Cool. So now we can say collection from iterable and give it an array or a generator or a database result object or an infinite list or whatever. We can concatenate things to it, call add. We can apply a map routine to it. And then whenever we're done, we call toArray, and then everything just streams out at once. And we get the results we're expecting. That entire class is less than 60 lines of code. Less than 60 lines of code to build a collection that is lazy, immutable, and pretty fast too, and easy to work with. We could also add type checking to it if we wanted to. Other libraries already exist that are more robust. Should you use this exact class like this? Honestly, no. The point here, the takeaway is you can add this kind of functionality to your domain-specific objects, your domain-specific list objects yourself very, very easily. Adding a map routine or a filter routine to a product list object, 5 lines of code. You're done. Can you add these to ordered sets? Sure. Add them to whatever you need to. That's the point. Purpose-built data structures with common functionality. What about the other side, associative arrays? When we actually do care about non-index or not integer indices. Well, there's 2 kinds to think about: lookup tables and the anonymous structs. But in both cases, there are better options. Let's look at lookup tables first. A lookup table is a map from an arbitrary value to some other arbitrary value. You can use integers or strings as the keys, but order is not really relevant here. This is really good when the keys are going to be user-defined or come from user configuration or something like that, where it's not something you can just code for ahead of time and just hard code all the values in. So you get a pattern like this that you see a lot, where we do some kind of logic and build up an array of key to some value. It's on line 3. And then we look into that lookup array by passing a value for the key, and we get back the corresponding value, and then we do stuff with it. Cool. That's useful. I've done this a lot myself. It's a common pattern. It's for good reason. Problem though, where's the error handling? There isn't any. What happens if the key is missing, if the value for request get header line has no corresponding builder? It breaks. Where's your type safety? Is what's coming back from that array guaranteed to have a build output method? No. How do we resolve these problems? By building our own lookup utility. We can start with using array access directly, if you like the array-like syntax. We do the same for type trick as before, with specifying the type we want. So that's how we get type safety. We could also pass in a default value. Now, offset set, we specifically check that the offset is a string. We have to check it here, offset set, the interface doesn't actually have a type check in it, so kind of have to add it ourselves. And we check that the value is of the type we want, and then save it to an internal array. Then when we call offset get, we return the value in the list internally, or the default value if one wasn't found. You could use other logic. This is what makes sense to me. And then offset exists and offset unset are boring, so we'll skip those. So now that error handling has been internalized. So you can call lookup for type, output builder, and give it a default of some kind. Then you build up the list. And now you're guaranteed to get back a value that is of type output builder. No matter what happens, you're guaranteed to get back an output builder object. It could be the default, but it's going to be an output builder. And if someone tries to put in something that's not an output builder, you'll get an error right when that happens instead of sometime later. Maybe you don't like array access. That's okay. It's actually slower. Array access is 3 times slower than a normal method call. So let's use a normal method call. This should look exactly like we saw before in the first half of the talk. We have a for type method. We have an add method that, in this case, we're going to have a string key instead of a numeric key. Okay. And then in this case, we'll pass a default in on the lookup method instead of on the constructor. Either way, whichever one works. At which point, we could also just make that a purpose-built service. So you have a builder map that is what we just saw, but with methods that are named appropriately. It has a builder provider that we were using before, and a default format, which is a string. So the default is going to be the key, not the value this time. And then the only public interface is the lookup method down on line 15. You pass in a key, you get back an output builder. It will lazily go through that same loop we saw before, and then return either the value that corresponds to the key you pass in, or the value that corresponds to whatever the default format is going to be. In practice, you'll configure all of this in your container. And now, using it is trivial. We've pushed all of that logic back into a service where it's not part of the API. That's not something an API user has to deal with. It's just something they get for free by using the API. All they have to do is call lookup, and they're guaranteed that if it doesn't fatal out, it's going to work because you're getting back a valid builder object. And all of the error handling is taken away from the end user and put back into a service where it's easier to unit test. And this is a win for everybody. How about anonymous structs? This is the case where the keys are known and they're fixed at development time, but you don't actually write it down. It's really, really common to see code like this, especially in code of a certain age. We have these kind of pseudo objects. This is an order with an ID, a total in some currency, a list of SKUs, whether or not it's been canceled, then the user that ordered it. Okay, fine. Is canceled spelled right? Does canceled have one L or two? Who knows? It's both. Depends. Are you in the US or the UK? Canceled is spelled differently, just to make life interesting. So which is it here? I don't know. Is USR supposed to be USER? Is that a typo? Or is just USR someone just is allergic to using vowels? They're a Web 2.0 startup. I don't know. Is it supposed to be an ID number? Or is it a user object that's supposed to be there instead of an ID? I don't know. Are those SKUs supposed to be strings or numbers? Because some of them are strings and some of them are numbers, but numbers are not the same as strings. So which one is the bug? I don't know. Do we support a single SKU as just a single value that gets upcast to an array? Sometimes that happens, sometimes that doesn't. Depends on the API. I don't know. Are there any other optional properties besides these? I don't know. What currency is that total in? Is that in dollars? Is that euros? Is that pounds? Is that yen? I have no idea. This is terrible. What's better? Put names on things. We now have a class that has all the same properties, but now we know, the string, the ID is a string, not an integer. The total is actually a money object instead of a number, which is good. It's called USER. It was a typo before, and it's of type user, not an integer. Canceled actually has two L's in it this time and defaults to false, so it's optional. SKUs has to be an array. Okay, we know that. And we know that there's no other values here we don't know about. Just by making it a class, we know so much more. It is not 100% better. Potentially, we could use a SKU list there instead of an array for all the reasons we talked about. But this is vastly better. And it's even more better, if I can say that, in PHP 8, where with constructor property promotion, we can now specify those properties in the constructor. They will become properties on the object. And we can then invoke the object or create a new object by calling the constructor with those properties named in arbitrary order. So we can even inline our new call, and we get a very self-documenting invocation, self-documenting constructor that will type check and will validate required and non-required fields, will validate spelling, all of those things for us. This is orders of magnitude better than using an anonymous structure in every conceivable way. Another pattern you see a lot is options. This is the second most useless variable name in history, right behind data. What are the values? I don't know. What of them are required, which are optional? What's the spelling? US or UK? Are there abbreviations? What are their types? How strict are they about their types? I don't know. Nothing about this tells me any of this information, which I kind of need to know in order to use this method. Okay, well, we could just document it and write it down. Oh, cool. So now we know the properties. Their layout, label, background color, which is spelled BG color, with US spelling instead of EU spelling. Good. And, oh, we're listing that twice because, haha, no one updates docs. We have a color and we have a font size. And font size has a dash in it. Okay, but people keep yelling at me that good code is self-documenting. If you have to document it, then the code isn't right. Well, good. Objects are self-documenting. Right there. we now know in code, in a way that cannot go out of date, we have layout, label, BG color, color, and font size are the possible options. Layout is required. The others are optional. We know their types. We know their default values. And we can then pass that in knowing exactly what we have. And we can even inline the constructor if we want to with named arguments because PHP 8 is awesome. But we can go further than that. Objects, besides having properties, can also have methods on them. So we can have a public static constructor if we want to, call it for layout because that's the one required value. Take the extras as named arguments that we can fill in. And then have other methods like set dark mode to force both colors or whatever else makes sense in your business logic for you to do. What's that going to be? I don't know. It's part of your domain model. You define the domain model that you want to have. At this point, though, we're putting all this functionality on the options object. We should turn the logic around. Put the format method on the options object. The options object is your executing function. So it'll take a constructor with a layout or a static method if you want to. It has dark mode, set colors, whatever other methods make sense to have on this object. And then when we're done configuring it, then we call format with the product we want to format. So instead of having a function that takes a product and a list of options, we first configure the function as an object and then invoke that with just the product. So we've now turned it around to being part of the domain model. And it's really easy to use. We create a new product formatter. There's the layout we want to use. Flip on dark mode, cool, and call format. If you're creating here a do object and then you're using it. If it has dependencies of some kind, all right, spawn it off of something in your dependency chain. Say one of your services, your theme system service, let's say. You call get formatter. That will construct a new product formatter object with the standard layout set and whatever other values. And then you can call whatever methods on that you want. Okay, it's going to have a dependency on the theme system. That's fine. It's not a service. It's a command object, essentially. And then when you're done configuring it, you call format on it, and it does whatever it's going to do. We have now completely removed the array. There is no array here. Everything we have is typed, is specified, is controlled, and therefore any error is going to get caught by your linter before you even hit save. Now, I had public properties in here, and someone is going to scream that public properties are evil. That person is probably me a couple of years ago. I have softened a bit on that stance. I would say, if you have a private object that's not part of your public API, it's okay to have public properties. At that point, they are a bit faster. It saves you typing, and you know everything that's going to use it. It's your own code, so it's okay. If it's part of your public API, then protect the properties and put meaningful methods on the object instead. Not just blind setters and getters. Meaningful methods that do something logical based on your domain. What makes sense based on your domain? I don't know. It's your domain. You tell me. You get to figure that out. But what about performance? I've heard that objects are big and slow. That might have been true in PHP 4. But is that still true? This is an old urban legend. It's true in, say, C, or it's maybe C++. Is it true in PHP? Let's find out. I ran these tests back on PHP 7.2. Nothing much has changed around array handling since then in the engine. But the basic test, I create a gigantic array of 1,000,000 items, where each item is an associative array with some garbage data in it. And then I'm going to sort it multiple times, not because I care about sorting, but just it gives me a way to work with and exercise the object and read values off it a lot. That's really all I'm doing here. And then I do the same thing with a list of standard class objects, objects with public properties, objects with private properties that have to access it through a method, and anonymous classes. And good benchmarking practice, run everything multiple times, throw out the high and the low, average it, and so on and so on and so on. Again, sorting isn't the goal here, just exercising the object and accessing values a bajillion times is the goal. What are the results? Well, for an associative array, for 1 million items on my laptop, it ran in about 9.4 seconds and used about a half gigabyte of memory. So that's our baseline. A standard class was 20% slower and used more memory. Never use standard class. Standard class is worthless. It has no place in PHP anymore. Just forget it exists. Don't use it ever. It has no value. An object with public properties on it was about 12, 13% faster. And wow, less than half as much memory usage. Less than half. With private properties, so you have to access it through a method, it got more expensive to read because you have the method calls in there, but still less than half as much memory. Anonymous class was actually slightly faster, but again, less than half as much memory. I expected it to be more efficient. I did not expect it to be this much more efficient. I was blown away at just how big this difference was when I ran these tests. When I published my results, someone responded, replaced all object-like arrays with classes, where they are used thousands of times. Memory usage reduced from 58%, by 58%, from 12 gigabytes to 5 gigabytes. What's he doing that uses 5 gigabytes of memory in PHP? I don't know. I don't want to know, but it's way better to use 5 gigabytes than 12 gigabytes. Whatever he's doing, objects more than halved, or less than halved, whatever the word is, his memory usage. And you can get a performance benefit too, a speed boost. If you care about performance, you will use arrays as little as possible. Let me say that again. If you care about performance, you will use arrays as little as possible. Why is this? Because in the engine, PHP has no idea what you're going to put in an array because it's untyped. With an object, it knows in advance what properties you're going to have and what their type is going to be. So it can pre-allocate the appropriate amount of space for each one rather than pre-allocating as much space as you might use. Incidentally, you get the same problem if you have an object and you assign a property to it that isn't already defined. It basically switches over and uses array-style memory handling and doubles your memory usage. Pre-define your properties. Define your values ahead of time. It is easier to read, easier to write, easier to debug, it is faster, and it is more memory efficient, tastes great, and less filling. So is there ever a use for an array? Some, but not many. They can be an internal implementation detail inside of an object. That's okay. That's fine. If you are returning an iterable or passing an iterable, then passing an array to that is perfectly fine because arrays are still iterable. You can still for each them. They work fine. If that makes more sense in your use case, that's okay, but it's still an iterable at the interface boundary. If you need to specify a callable, that's kind of all we can do in PHP right now. Hopefully 8.1 will solve that. More on that another time, but for now, you have to use an array there to specify a method as a callable. If you are passing named arguments to a method, you can use a dynamically built associative array for that. That's PHP 8 specific, that's in a very narrow little place. And in generated code, fun little quirk here. If you are compiling out code to disk, say a compiled container or a compiled event dispatcher or something like that, then a constant big nested array will take more memory, but that memory is in shared memory, not process memory. So if you have 5 simultaneous requests, that memory gets used once instead of 5 times. depending on what you're doing, the data may end up copied into memory anyway, so you don't always get a benefit from it. But compiling it out to an array may in some cases be faster and more memory efficient. But you still then want to turn it into an object when you return it to a caller, because you want that better API that you can build for your system rather than just blob of array. So really, don't use arrays ever, at least not in public where people can see you. Thank you. Hope you enjoyed, found that interesting. Again, you can follow me online at Krell on Twitter and most other medias. I've got a number of books available. Exploring PHP 8 is free, but you can also offer donation. And Thinking Functionally in PHP, available now. And we'll be giving away a copy in a little bit. With that, I turn it over to questions. And I will put a link to the slides in the chat here if you want to follow the links, as well as some links to the books. So if you have questions, go ahead and ask them in chat or unmute yourself. I'm good with either one. What do I think of the PHP data structures extension? It was a really good idea in PHP 5 when they were first created. They haven't really been updated that well since then, so I'm not sure that they're much of a win anymore. I haven't actually used them. I would love to see something like that in core, but there's a lot of debate around the best way to do that. And every time someone mentions it, we talk about generics instead, because that's how internals works. I think you're going to refactor over time. That is the best way to do it. But yes, generally, you follow the campfire rule, always leave code better than you found it. And better than you found it generally means fewer arrays and more types. In almost every case, fewer arrays, more types is better code, at least in PHP. I wouldn't forbid arrays in your CI system, because you do still need them inside of your domain objects at times. But you can definitely, warn about using them in a type hint. There are very, very few cases where an array in a type hint, a type declaration, is good anymore. Iterable or a dedicated object type can replace them in almost every case. So that might be an interesting thing to add to CI, is not a block, but a warning of any time you add array as a type hint. It's probably, there's a better option. Question, wondering if the memory increase is as much when values are significantly larger than keys, because most memory is due to how PHP arrays are actually sorted, linked. I'm not sure there. If you have a string key, then the key's size is included in the array memory usage. If you have an object property, then I'm not sure that the property name length has any bearing on memory. So I suspect it would not be a massive difference unless you have, 500 characters array strings, or array keys, but I'm not actually sure there. If you putting an array definition into a PHP doc, if you're doing that, why don't you just actually make a real type for it that the engine will enforce for you rather than relying on a third-party linter? You're going to get you'll get a better result out of that and a more efficient result in most cases. Mark says the real key is actually stored in the hash, so it's a fixed size. That could be. I'm not super familiar with the internal implementation of arrays at that level. BD asks, is my book also available in paper? Not currently. I'm hoping to do a second edition of it this fall after PHP 8.1 comes out, because fingers crossed there will be some really big improvements in 8.1 around functional programming. I'm working on them right now and bribing people to make them happen. So I'm hoping that the second edition will be even better, and I can do a paper version of that. No guarantees, but right now it's ebook only. If you want to print it out yourself after buying the ebook, you have my permission. And I'm being recorded saying that, so it's okay. Benny asks, in the example I used array search internally, is that slower than for each? I don't actually know. I'd have to benchmark it to find out. Array search was shorter, so I put that on a slide. In practice, I'd have to benchmark it to see which one is faster as an implementation detail. I'm not actually sure offhand. One interesting catch there is your definition of equal. So when working with objects, equal is going to be defined as has the same ID. Excuse me, identity is defined as having the same identity, the same, like literally the same object in memory. Double equal is weird with objects. So if you have a collection of objects, you do need to be careful about what you're defining equal to be. It would be lovely if PHP had a built-in equals comparison in the engine that you could put on objects, but it doesn't. That RFC was rejected. Someone do a better version of it, please, because I want that too. Yeah, and Mark says array search is probably faster. I would expect it to be faster. The question about how it defines equals is possibly tricky. I'm not certain of that. In practice, I almost never use array search myself. I just don't need it. So depends on your use case. Weak maps. Oh, weak maps are fun. So a weak map is an object introduced in 8.0 that implements array access and accepts objects as its key. However, that object as its key does not count towards the reference count on the object. So let's say it's mainly used for caching. So let's say we have a we're loading posts, blog posts out of a database, and then we're going to lazily load all of the comments on each of those blog posts and render the comments. All right. And then we want to cache that in case we use it multiple times. Contrived example, but it's the kind of the standard example here. So we have a weak map that contains the key is the post object, and the value is the rendered bunch of comments on it. If that object goes out of scope elsewhere, we no longer would have the ability to look up that comment cache. So we don't need that line in the comment array anymore. But if it's just a normal array, then, or a SPL object hash, then that would count towards the reference count, and so the object would not get garbage collected. With a weak map, it doesn't count, and so when we lose all other references to that post object, the post object goes out of scope, it gets garbage collected, and the entry in the weak map gets removed. So both the post object key gets cleaned up, and the rendered comment string gets cleaned up. So both of those now get garbage collected. That's a weak map. It's useful in certain caching situations, like what I just described, and that's kind of it. Certainly, I would say wrap if you're going to use that, also wrap a nice API around that in your own object. It's very light overhead. And then it just becomes a self-cleaning cache. So when the key goes out of scope elsewhere, the key gets garbage collected anyway, then your cache based on that key also gets garbage collected. So that's weak maps. Mark says array search does have a strict mode for comparison, so you can turn that on as appropriate. Cool. Yeah, a lot of the array operations have a strict flag, which does double equal versus triple equal. In 90% of cases, you want to use the strict flag just to avoid PHP type weirdness. Why an object of any of these discussed types could be faster or use less memory. So that is specific to anonymous structs versus a defined class. If you have a linear array of 50 items, then and those items are all a string, then that's going to be an array. That's all you can do. You're done. Specifically, if you have a like an order array that has keys inside it that are values, so it's kind of like that pseudo object, that versus the object equivalent of it, the object is what is faster and more efficient. Does that clarify that? Yeah, that's specifically what that benchmark was testing. So yeah, I'd say the biggest offender here are anonymous structs. Using associative arrays as if they were junior objects is probably the biggest design flaw in PHP code that dates from PHP 4, or developers who grew up in the PHP 4 era before we realized that objects were so much better. So there's a lot of code like that. And my goal here is to tell you don't do that anymore. There are vastly better ways, and every version of PHP, the better ways get even better. Have I implemented structures similar to these in one of my projects? Yes. The self-sorting logic is derived from code I used in Tukio, which is my PSR14 implementation. What I do there is I have an ordered list object, and it has some complex logic around how the ordering happens. But the API for it is take values, toss into object. Object has more than just an array internally. It's more involved than that. But it will then lazily reorder everything and return it in the correct order. It also has a flag that it tracks to see if it has been ordered yet or not, so it doesn't have to reorder things if it's already been ordered, and stuff like that. So that is used in production code that I've written. A lot of these others are things that I've done in bits and pieces, or I'm going to be using it a lot more now that I'm back to doing development full time. The last 5 years I was doing developer relations, so I was doing fewer real projects. But generally speaking, I have followed the principle of replace an array with a real object and put a nice API on it, and the code gets better. And that has been very consistent in my experience as, yes, that is better. Collection classes. Would I recommend using one of the existing like Laravel or Doctrine collections or build my own? I have to look at those specifically to see what else they're doing. My honest inclination, if I'm doing just a one-off library, would be to just re-implement the pieces I need myself, because I can get type safety on it that way because we don't have generics, and I can build on the pieces I actually care about. I can make it lazy with generators or not, depending on if I want it to be as fast as possible or scale to as large as possible, because using a generator there is slower than just having everything be a real array up front. But the generator version can also be lazy, so it doesn't use as much memory overall. Which trade-off I want is going to vary. So I Jan Martin is saying that a lot of them make things worse because they do more array magic. Could be. I would have to look at them specifically. I haven't bothered releasing this array or this collection library because again, it's 60 lines of fairly boring code. So my first inclination would be to just re-implement the pieces I want myself. If I'm using it a lot, then I might look at one of the libraries then and see which one I like. But I just haven't done that survey yet. Or again, building one myself is not exactly hard. That said, the ability to have a nice fluent map and map, filter, and reduce method chain is really nice. It makes for some really nice code. So I do endorse that, however you get there. Yeah, a lot of the existing collection libraries do assume database interaction, which I'm not sure is actually a good idea. You should be doing that logic in SQL beforehand. That's kind of what it's for. And the SQL is going to be faster than you are 99% of the time. Oh, don't use the basic SPL libraries. Or the SPL interfaces are fine. Generators, iterator aggregate, those are all fine to use. But SPL doubly linked list, SPL queue, SPL ordered queue are buggy and broken and terrible. Don't use them. Please don't use them. Yeah, so the iterator interfaces aren't using the data structures. Those are fine. Those are safe to use. But the data structures that you in SPL that implement those interfaces are mostly crap. I actually considered using the SPL ordered queue in my ordered list library for 2Kio, and it was horribly buggy. It just was unreliable. It did not return things in order correctly. So yeah, don't. It is better. It is more reliable and faster to just implement my own than try and work around its bugs. All right. There's no more questions. I think I will turn it back over to the organizers for assorted giveaways.